Today we're doing two of our laws. Two of our laws of exponents. Here's our first one. And these laws are happening when you have the same base. What does that mean when I'm saying that the two terms have the same base?
Or number or variable exponent. Yeah.
That has the exponent. So the same number that has the exponent. So do these share a common base? This first box.
Yes.
What's the base? Right. So they have the same base, and what is happening to those two different, or to those two same bases? What's the operation? Multiplying. So that's gonna be your first law. What happens if we're multiplying things that have the same base? How does that affect exponents? Well, let's test it. Can you calm down for a minute? Okay. So expanded. That's our first step. So f to the power of 6. What would that be if we expanded all the way out? What do I have to do? Right. How many times do I have to write it? 6 times. And then f to the power of 5. That really means 1, 2, 3, 4, 5. Okay. Well, what do exponents represent again? Repeated multiplication. So what do we have going on here? How much repeated multiplication do we have? 11 f's. We can count it all out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 f's. So we can simplify it because today, starting today, I will always want everything as simplified as possible. The directions will always say simplify. That means as much as possible. That means if we expand it, we have to bring it all together and condense as much. So let's look at the third box. D to the power of 3, d cubed times d. D to the power of 3 means what? What would it be if we expand it? Okay. And then this one is just d. So then that's the expanded version, but what's the simplified? Bring it all together. D to the power of 4. Okay. Let's look at the last one. Go on to x's. X squared. That would be x times x. X to the power of 4. 1, 2, 3, 4. And then x cubed. That's the expanded version, but I want the simplified version. X to the power of 9. Have we made a conjecture or an idea of what we think the rule is? Do it with y's. Try and do that y one without expanding it. Or expand it if you want to. It's up to you. What is it?
Easy.
Y to the power of 10?
This is addition.
It is addition. If they have the same base, you are adding the exponents and they are multiplying together. Now, I understand that might seem simple. We're going to be doing where it's like 4 laws in one problem. So that's why we're kind of breaking it apart a few at a time, because I know that y'all are probably like, God, this is like the easiest thing you've ever done in class. We have to just stay on top of it, because it's going to come together where we have to just take our time to be careful. Silly mistakes are the most mistakes made in this. We're just not paying attention that much. So, we're adding the exponents. That is correct. Keep in mind, this is applying for, we're adding the exponents when their bases are the same. So when they're being multiplied and their bases are the same, you add the exponents. Now, all of our exponent rules are actually on your formula chart. There's a little box that says, or a little section that says properties of exponents. But in that properties of exponents section, it's worded a little funny. And what I mean by that, you have to somewhat have an idea of what the rule is to follow along with what it says on here. What is it called when you have the answer of multiplication problem? A product. So it's labeled as a product of powers. And on your formula chart, I'm going to copy exactly what it says on there. It says a to the power of m, and then a to the power of n. Do those have the same base? What's the base that they both have? A. and that's multiplication. So that means it's going to be m plus n. That is what's on your formula chart. What I think you should try and focus on is that part. M and n are always going to be your exponents on your formula chart, so look at what's in between the m and n. What operation's happening with m and n, that's what you do with your exponents. And then we're going to skip that last part.
Yeah.
Where we're going to go is not the back of this front page, but the front of the next page. So this page. Because there are some on here that are a little bit different than what the examples we just did. We're going to step our game up a little bit. So, look at number 3. That's where we're going to start. On number 3, let's go back to expanding it. 4x squared. That means this would be 4, and then x and x times 3x to the 5th. We need to simplify this all the way. What can we do first? What's something we can do? 4 times 3. Coefficients, numbers are still just regular numbers. We're multiplying them. So what is 4 times 3? Okay. And then x's, well, all the x's are being multiplied together. So write that with our exponents. So x to the power of 7. Good. Okay, let's try another one. Y'all pick. What's one you want to do between 4 and 8? Any number between 4 and 8? 6? All right, I heard 6. We're going to do 6. All right, let's practice the expanding version again. Negative 4a to the 3rd power and b. And then 3a, and then 1, 2, 3, 4, 5. 3 to the 5th power. The numbers, the coefficients are going to multiply. So what's that going to give you? Negative 12. And what do we get for the a's? A to the power of 5. And what about b's?
6.
B to the power of 6. Now something to be careful about. We just learned a rule. We learned that we can add the exponent. Look at the b value in that first part. Do you see an exponent? But if you don't see one, what's the actual exponent that's there? A 1. So keep that in mind if you're going to try and skip the expanding part. You got to keep in mind that there's a 1 there, so you have to add it.
So you can just count the number of p's and like expand.
Yep, that's exactly right. Especially in the beginning, I would suggest expanding it a few times. That way, eventually, your brain expands it and you don't have to write it down. And then it makes a little bit more sense. But expanding it, especially in the very beginning, is helpful. All right, so let's look at numbers 10 through 15. Pick one you want me to do.
14.
All right.
15.
I heard 14 and 15. How come all fractions? Oh my gosh. All right, so let's do 15. If we're doing number 15. Coefficients can all multiply. All the coefficients are normal multiplication. What are the coefficients in that problem? 1/4, 8, and negative 6. So that means we're multiplying 1/4 times 8 times negative 6.
2 times negative 12.
Which is negative 12. There we go. M times m squared. That means how many m's would we have to expand out? 3, so n to the power of 3. And then n times n squared. Also n to the power of 3. Tell us the fractions here. That one.
13.
Okay. So then let's go down to the bottom part. We're going to do numbers. We're going to do number 17. So on number 17. What's different? Okay, so what are the different operations in that expression? Multiplying and adding. What's going to go first? Multiplying. Okay. So that means we need to multiply this part. And then we'll have to multiply this part. We have to multiply them separately before we can add them. Now multiplying this first part. Coefficients get to multiply together. So what am I actually going to multiply? 5 times 4. Coefficients are 4 and 5. So 20.
And then
We have a cubed times a. So how many a's would I have to write out? 4. So a to the 4th power. And then b to the 4th power times b squared. How many b's would be written out there? 6. So b to the 6th power. Plus sign is still in the middle. We'll deal with that in just a minute, if we can, because we can only add and subtract things if they're like terms. So let's look at the next part. Are there coefficients to multiply? There's a 1 times -2, which is -2. What do you get if you multiply the a's? A squared times a squared. How many a's would be written out if we expanded it? 4 of them. And then b to the 5th power times b. How many b's would have to be written out? 6. Is there a 5 here and there's one more there? There we go. All right. So we multiplied. We did all our multiplication. Now it comes to addition. We can only add things if they are like terms. What does like terms mean? Same. What do you mean by same? And not coefficient. Exponent. Terms are like, they are like terms if they have the exact same variables and exponents on those variables. So those match up exactly.
Yeah.
A 4, B 6. That's good. A to the 4, B to the 6. So they're good. That means we can combine them. So we're combining our like terms.
So it was like E3. If it was A3.
Correct. If there was an A to the 3rd power and this one was A to the 4th power, you would not be able to combine them. Like this. Like that.
Yeah.
You cannot combine those.
That's your power function.
It has to be the exact same variable with the exact same exponent on top of it. That would be your final answer. If you can't combine them, then you're done. But these are exactly the same. They both have A to the 4th and B to the 6th.
You also, the 20 and the negative.
Okay, that means we combine them. Combining means add the coefficients together. So 18. And when we combine like terms, we never touch a variable. We never touch the exponent with the variable. Combining, adding, subtraction does nothing with letters. Just coefficients. So A to the 4th, B to the 6th. Do not go all crazy on me. You have been combining like terms since last year, 2 years ago, a while. Combining like terms just means you're adding the numbers in front, the coefficients, or subtracting the numbers in front. Don't start going crazy and changing and doing things to letters when we're adding and subtracting.
But you wouldn't like add the exponents?
No. The only time we add exponents is when what operation can become? Product, which means multiplication. Okay. So let's go to, we'll come back and do another one if we need to. Let's do some division, because we'll see another problem similar to this later on. So we'll come back if we need to. So let's go to the division part. We are dividing polynomials at this point. So if we're dividing them, do these have the same base? Okay, then that means there's something that can be done with this. It can be simplified. So we're going to go back to how we did it before. We're going to expand it. The back of the front page. Back of the front page. Okay. M to the 7 over n squared. So n to n. Okay. Now when it comes to division, what happens if you have something divided by itself? It cancels, right? Okay, it cancels, it becomes 1. Yes. So that happens there, and it happens here. So can we cancel out anything else? That means we're ready to write our answer. N to the power of 5. Okay, let's try another one. Let's do the B's. Okay, so we're doing those B values. B is cubed over B squared. These can cancel because when something's divided by itself, it becomes a 1. So what are we left with? B to the power 1 or just B? Okay. What about, let's see, are we figuring out maybe some sort of pattern?
Yes.
What is it?
Whatever's left is your answer.
Right. So if there are going to be 8 on the top and 3 on the bottom, we're going to be left with k to the power of 5. What about this last one, the x's?
0.
Oh.
No, it's 1. No, it has to be
What were we talking about? What's m divided by n? 1. Because when you divide something by itself, it's 1. So what's happening here? It's dividing by itself, so what is it? The answer is actually 1. We were dividing x to the power of 9 by x to the power of 9. If you subtract it, it's really x to the power of 0. Preview for one of our other rules. Any power of 0 is good. We'll do that Thursday or Friday. Alright. So what's the general rule? If they have the same base and the operation is division, what do you do with the exponents? Cancel, which means subtracting the exponents. We are not going to worry about it. Instead, we're going to go straight into what does it say on your formula chart. So on your formula chart, what's the result of division? What is that called? Quotient. There we go. So this is called your quotient of powers rule. And exactly what it says on your formula chart. If you have a to the power of m over a to the power of n, do those have the same base?
Yes.
What's the base of those? They're both a. That means it can be condensed and written as one base, but what do we do with the exponents? Subtraction. So, once again, the thing I would say focus on and look at, find m and n on your formula chart. What is happening between those two variables? That's what you're going to do with the exponents. Okay. Now flip to the very back of the second, or the back of the pack. So the back of the second page. And let's go to number 8. Okay, you want to jump into the hard one first? No. I was going to start off a little bit easier, but let's go. Let's do it. Okay. So, on number 8, let's say we're expanding it. Negative 15. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Then on the bottom, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. That's the fully expand version, but we just have a little bit more than what we had before. What's the like the general operation? What is happening when you have that bar? Canceling because it's division. You're dividing things. So what's going to happen here? It's numbers. It's normal division, the coefficients. Just like multiplication, we just did whatever with the coefficients. We're still going to divide those coefficients. Those are still treated normally because they are normal regular numbers. So what is negative 15 divided by negative 3? 5. Okay. Then when it comes to our x's and y's and z's, that's where things can start to cancel. This cancels, this cancels, this cancels, this cancels, and this cancels. So what's left for x? Just an x. And then in terms of y, we've got this canceling, so y squared. And then z, there was no z on the bottom to change it, so we're going to say s. There's your answer. Okay. We're going to do this bottom right one. So the very bottom right. Before we started, look, what are the operations happening in that problem? There's division, subtraction, and multiplication. So there are 3 different operations. Subtraction can be left. What? Anyone have an idea where we can start? Okay. Multiply the top part. So let's go back to that multiplying. Coefficients multiply with coefficients. So 8 times negative 3. Negative 24. And then what's the new exponent for my c variable? We have a c here and then 4 more c's there, so c to the power of 5. And then d cubed. And then the bottom is staying the same. We haven't done anything yet. And then minus c cubed d squared. Those of you that like to not show work, this section is going to be the section you want to show work. There's going to be lots of steps where you want to actually write it out because it's going to take some time. What's the next step you're going to have to do here? Divide, because we have division and subtraction. Division goes before subtraction. So we're going to divide these. Coefficients divide with coefficients. So this divides. What's negative 24 divided by 6? Negative 4. The rest, we're dividing variables when they have the same base. So what do you do with the exponents? Subtract them, because this is 5 c's up here and 2 c's on the bottom. When they cancel, how many c's are left? 3. So c to the power of 3. And then if we have 3 c on the top and then 1 c on the bottom, we're going to be left with 2. The minus 9c cubed and d squared stay the same. Now, final step. If we can, subtraction and addition only happen if you have like terms. Are those 2 things like terms? Yes. They match for exponents with their variables. What do you mean which one do you keep? Combine the terms. Negative 4 and negative 9. Combine it. All right. So